Okay, Putya, I'll start by summarizing the things that you have learned up to now, last day even, like we started the lesson, properties of matter. So we learned status of matter in previous chapters. In grade 6, 7, we learned status of matter. So we learned there are three: solid, gas, and liquid. Solid, gas, liquid. We learn about that. So, and their behaviors, basic properties. Here, actually, we are exploring that further. So what we learn about matter and energy in grade 6. And so in the next stage, we are now exploring further and we are going to learn about properties of matter. Properties of matter. Right? Then in the properties of matter, under this, in properties of matter and under this, we will be learning about each matter type as well as its behavior, right? So then, so first of all, I said you, please categorize these things into whether, so please identify whether these things are energy or matter. Energy, sometimes plasma. So this energy, things like electricity, heat, and sound, so those are not taking any space, right? Light, right? Light, sound, electricity, heat, not taking any space, right? Not having a mass. And therefore, these are called energy. But in the other hand, air, water, bulb, table, chair, magnet-like thing, it needs space and having a mass. So those are called matter. We learned about that last day. The things which take space, ඉඩක් ගන්න, and things which have mass, බරක් තියෙන දේවල් අපි කියනවා පදාර්ථ කියලා කියනවා. පදාර්ථ නැත්නම් we call them matter, and the other things. So energy or plasma, it's not taking space and it's not having a mass. That is how we measure these things. Right? So, but still you can see light, you can see sound, you can hear, electricity, you can feel, heat, you can feel. So these things are there in the nature, in the environment. Only thing is not taking in space and not having mass. We can't measure it, right? We can't keep it inside something and we can't measure it. But so in the other, other hand, you can say the light, the powerfulness of light you can measure, but mass you can't measure. The powerfulness of sound we can measure, decibel. Light we can measure. Electricity, voltage, ampere we can measure. But the thing is, we can't measure the mass. We can't also keep it in some container, right? Keep it in some container. You can, and anyway, like you can emit or you can generate it, but keeping it in the same state as in a container is again difficult, right? Because it is always, the energy is always converting into some other format, right? It's with the environment. If you have seen sound, so if you emit a sound, then if I emit a sound, you can hear, but what will happen? So if you go to some, okay, let's say you are kilometers away from my voice. So let's say you are not using Zoom or any other technology and you are in my room, then you can hear me. Maybe you are in the house, still you can hear me. You are in school, still you can hear me if I'm in the school. But you are outside. Let's say you are in one city and I'm in one city. If you are not using Zoom, you can't hear me. Then what has happened to the sound? The energy format that I have generated, it will be converted to some other energy. And so it's not vanishing, it's not destroying, but it will be converted to some light also. So when light hits some surface, some light, some of these will be absorbed and some are not. And after that, the absorbed and the reflected. Even the reflected light will be last only in that format for some time, but after that it will be converted. So that is the nature of energy. Electricity will be converted. That is why we can't keep it forever. It will be converted. That is another nature of this energy. Actually, we are not learning energy in this chapter. We are learning about matter. Right? Energy we will learn in another lesson. Okay. So then we learn about two philosophers. So one is Democritus and the other one is Aristotle. Both were arguing about this energy. Both were telling various their ideas about the energy, but that is before Christ. It's in the ancient time, 2000 years ago, they were expressing, they were telling about that. And Aristotle, right? So these two people, these two philosophers, they had two ideas. Right? Democritus, he was telling, right? He was telling something, and the Aristotle was telling something. He was opposite actually. Right? Here, Democritus said, matter is made with small particles. Anchually, make a hadilati. Matter is made with some particles, small particles. So we also test, we have learned a test last day, how you can take a chalk and divide it to two pieces. Chalk and take a piece and divide it again. Take a piece, divide it again. You can do this continuously until you can find the smallest unit. So that also has same properties like the original that you had. So means the matter is made up with particles. That is the experiment. Chalk එකක් අරගන්න දෙකට කඩන්න ආය දෙකට කඩන්න ආය දෙකට කඩන්න ඔය විදිහට පුංචිම කොටසට කඩලා බලන්න ඒත් අර chalk එකේ ගතිගුණ තියෙනවා. Right, similar to that. So the chalk will get that same properties. So that is why we call it is made up with small particles. So that is not just for solid, that can be applied for liquid and gas. Can you remember the experiment we did for liquid? Yes. So what was the experiment, Sanidhi, for liquids? How we can see the discontinuous of liquid? Yes, discontinuous. Or how we can check whether it is created or it is made with small particles. How we can test this? Yes. Just tell me how we can test. Yes. Can you remember? Liquid also you can. Yes. Sanidhi. No. Oh yes. Okay. Liquid also you can divide, right? Liquid also you can divide. So this is for the chalk. And another thing that another test that we have done, that is like, I asked you to keep this. I asked you to keep the chalk in some ink. Then after some time, if you monitor, I asked you to do a time lapse. I'm not sure whether you have done. So still you have not shared it with me. So earlier time, actually, when we start the classes, you were doing practicals, but I don't know whether you are doing it now because you have not shared this with me. Anyway, if you have done, please share. So I asked you to do a time lapse in video. Time lapse in video, you know, time lapse means you have to keep the camera steady. And there is a mode called time lapse in the camera, right? So,
okay, sir.
Yes. Yeah. Frequently, you have to take a picture. Actually, camera will automatically take the picture frequently. Let's say 1 second, it will take one picture. 1 second for one picture. Separate එක photos ගන්නවා කියලා හිතමු same angle. So let's keep it for 5 minutes. How many photos it will take?
5 photos.
No. 1 second, one photo. You keep it for 5 minutes. It will take 1 second, one photo. Yes, 300 photos because 60 seconds, 60 photos. 60 into 5, 300 photos.
Yes.
Right? Then it will take 300 photos. What will happen if it takes 300 photos? Then you have to play like 25 photos per. Let's say you are paying 25 photos per second. තප්පරයකට photo 25 ගානේ play කරොත්. So this 300 photos you can play closer to 12 seconds. Right? තප්පර 12ක් විතර play කරන්න පුළුවන්. So that's like looks like a video. So we call them time lapse, right? You can remember here. I'm not sure whether that practical was there in YouTube, but anyway I suggested you to upload that. chalk in time lapse. So when you time lapse, you can, no, it's not there. But let's say, let's see some other time lapse, maybe candle time lapse. So that is a very simple example. Here, this is a candle. So what happened? You have to take, right here, you have to take frequent photos and then quickly play this. Then you can see when you play this, it is running faster, same angle. These are photos actually. But these photos running faster, you can see that as a video. That is what time lapse is, right? When you play it, it's playing faster. And you can see it's melting very quickly. Similarly, you can put the chalk in ink and test. And then you can observe it is melting. It's not melting actually. What you can see, you can observe that ink is moving. Ink is moving towards. It's moving up. It's moving up through this medium chalk. Means it is discontinuous. Why? Because there are spaces between these. There are spaces between these particles. මේ අංශු අතර ඉඩක් තියෙනවා. එහෙනම් තමයි තින්ත උඩට යන්නේ මේ අංශු අතරේ. That is another feature of these matter. The matter වල feature එකක්. එක property එකක් තමයි discontinuous nature. එතන ඒක මුලින්ම එක ගැන අදහසක් කියපු එකනා තමයි මේ ඩෙමොක්‍රිටස්. එයා කිව්වේ ඩෙමොක්‍රිටස් කිව්වා මේවා අංශු වලින් හැදිලා තියෙන කියලා. වෙන දෙයක් නෙමෙයි. එයා කිව්වේ නෑ ඒක discontinuous එහෙම කතාවක් කියනවට වැඩිය එයා කිව්වේ මේක අංශු වලින් හැදිලා තියෙන. This is made up with particles. To test that, we have done this practical. One is dividing this into small pieces and see the properties. The second thing is you can test like this and you can see the ink moving through this. Similarly, you can do, so this is, don't do this practical. So I think Sanidhi, you said you can find chemicals since your mother is a teacher, but the thing is don't do this practical because this is going to be expensive practical. When gold and mercury, right? When gold and mercury mix, what will happen? So mercury will, right? Mercury will also go through gold. That will destroy the jewelry, right? That will damage the jewelry because the gold, you know, gold is really valuable. The mercury may mercury is a special metal. Why? Normally metals are in solid status, but mercury, what is the status of mercury? Is it solid status or some other status? Mercury can rasadiya. So normally most of the solids are in, most of metals are in, metals can be loha. Most of metals are in solid status, but mercury, if I have not seen, let me show. But this reaction, it's rare because like it's expensive reaction. People will not like to do this reaction because it will destroy the jewelry. Mercury and gold, actually that will destroy the jewelry. This is something. But this is a paper, gold paper. So you can see this gold is also a metal that can also be in, mostly it's in solid status in the room temperature. This is gold sheet.
In a process known as amalgamation. For this video though, I'm going to be focusing on its interaction with gold. And to do this, I bought some gold leaf off Amazon. I cut out one of the pages, put it in a bowl, and then I start to add the mercury. I was honestly surprised with what happened, and I thought
so see, this is mercury, right?
Gold where it landed and make a hole in the leaf. I think if I just put one large drop, it would have pulled the entire leaf in, but because I used multiple drops, they kind of started battling and eventually ended up in a stalemate. I tried to speed things up by adding several more drops, which initially seemed to work.
So these drops are actually mercury. So that means mercury is in, what is the status of mercury? It is in liquid. සාමාන්‍යයෙන් ලෝහ තියෙන්නේ solid විදියට. හැබැයි mercury කියන එක රසදිය තියෙන්නේ දියර විදියට. Have you seen mercury thermometer?
Yes, teacher.
Right. So to measure the temperature, so you can use this mercury thermometer, right, to measure the temperature. This is all thermometer, not the digital one that you are using nowadays. All thermometer, it has mercury. It's highly sensitive to the temperature, right? It's expanding when temperature is high, so it's moving up when temperature is high. That property is used to measure the temperature of your body or some other object. So that is all thermometer, mercury thermometer. So it is a liquid. That is also you need to learn. Okay. So then, right, discontinuous nature. So this even gold and mercury show the discontinuousness. Liquid. I asked you to put small drop or small piece of condis. We can say potassium permanganate. So if you put, right, if you put small crystal of permanganate to water, initially you can see it's fading out. But if you like shake this flask, or if you shake this beaker slowly, then you can see it dissolves. It dissolves and it spreaded through this. Ultimately, color of water will be purple. So that is the color of permanganate, right? It is really colorful element, so we can use potassium permanganate. So that also shows why this is colored, because these particles of permanganate is actually, permanganate is also actually made with particles. Permanganate අංශු වලින් හැදිලා තියෙනවා. ඒතර වතුරත් හැදිලා තියෙන අංශු වලින්, ජල අංශු. ඒතර ඒ අතර ඉඩ තියෙනවා. So permanganate is moving towards, and permanganate අංශු වලට කැඩෙනවා. වතුරත් අංශු අතරින් ගිහිලා තමයි මේ පාට තියෙන්නේ. That is why you can see that is the discontinuous nature of liquid. Discontinuous nature of air. Either you can use right jar, gas jar, and you can use lighted joystick. So that is in your home environment, or if you can use nitrogen dioxide, which has this brown color air. It's a brown color air. So then you can see that is also spreading. Right, that spread into the other gas jar, right? So that means air is also discontinuous. That is why it's moving towards the negative සාමාන්‍ය වාතය, මේකේ තියෙන nitrogen dioxide, දුඹුරු පාට එක, මේ දෙක එකතු කරාම මේ gas jars දෙක එකතු කරාම එතකොට මේකේ නම් මේකට යනකම් මේක spread වෙලා අන්තිමට මේ විදිහට දෙකටම spread වෙලා තමයි නවතින්නේ. The reason is the discontinuous nature of air. Okay. Then we can see, and now we know the discontinuous nature of each, right? Discontinuous nature of each. So then, since you have observed the discontinuous nature of each, so let's see how these particles are organized inside. And so what kind of properties given to the element, what kind of properties given to this thing, matter, due to this particle arrangement, right? Particle arrangement, and also what kind of properties are given due to this particle arrangement, right? So I'll give the summary note after this, right? Don't worry, I'll give the summary note. But since we need to save some time, that is why I'm not focusing much on the note, but definitely I'll give the note on this, a summary, right? Then, okay, solids. So this in solids, actually I saw this in the previous one also, if not, so I'm not sure whether I have done that in grade 6 or not. So let me open this PowerPoint. If I have done this in grade 6, I'll show it again, right? Anyway, so let's go through your book. Particles in the solids are well organized and it is orderly arranged. Therefore, particles cannot relatively move. It is not possible to relate. So they are actually, these particles are moving, not moving. Actually, we can call particles are, I'm not sure they have done this in, let's see, this one. No, it's plant diversity. I think it's need to focus on status of matter. Status of matter, not this one here. Yes. Okay, so this I have done previously when discussing about status of matter. And so you can see in the solid, the particles are organized and those are strongly placed, but they are not showing any relative movement. Actually, this shows the other thing, right? How solid is converted to liquid by melting. This is the property of melting. So this is solid side. Let me mark. This is solid side. And this is liquid side. Solid side, please see. In the solid side decay, please see what's happening in the solid side. Particles are moving, but it's not displacing or it's not moving relatively. So basically, it's in the same place. එකිනෙකට සාපේක්ෂව යා move වෙන්නේ නැහැ. Right? එකම තැන වගේ තමයි තියෙන්නේ. හැබැයි එකම තැන ගැස්සි තමයි තියෙන්නේ. එයාත් move වෙනවා. So even solids, we can't see this, right? We can't see this in a, so let's say iron or copper. Just take piece of iron or copper. Iron, copper වගේ එකක් ගන්න. ඒ අරගත්තන් පස්සේ වාට මේ පේන්නේ නැහැ. අරගත්තම පේන්නේ නැහැ මේ ඒවා move වෙනවා. හැබැයි මේක ඇතුලේ ඇත්තටම inside this, if you really see, actually these particles are moving. Right? Particles are moving, but you can't observe them. But liquid you can observe. Liquid will not pay now. Right? You can see. So if you put water into a jar or water into a flask or beaker, so when you shake it, you can see it's the entire thing is moving. But it is not moving everywhere. It is not moving everywhere. Only take the space relevant to that. එයාට අදාළ ස්පේස් එකේ තමයි එයා move වෙන්නේ. හැබැයි මේකේ හැමතැනම move වෙන්න ගන්නෙ නැහැ. මේ වාදනයේ පුරාම move වෙන්න එපා. එහෙම වෙන්නේ නැහැ. අපි හෙලෙව්වොත් තමයි එහෙම වෙන්නේ. Otherwise it's like it's continuously moving, right? It's moving and it keeps its continuity. But air in other hand, so let's see air here. You can see this is liquid and air, right? See the property? Liquid and air. Liquid and this is air or gas. So when it becomes gas, see what happens. It's moving here and there and everywhere in the container. It is not keeping any continuity. It's not keeping the bonds. It's moving here and there. So it has the gap is really more than this liquid. But in solid, gap is very, very low. Liquid, there is a gap, but gap doesn't affect because those are moving. It keeps the gap and moving. But here, since the gap is there, it's moving even to every extent, every corner of the container, it will move. So that is there in the gas. Okay, let's see what's there in the book. Okay, solid. Particles are arranged orderly, and so particles are strongly bonded. So this link between particles is very strong. Particles do not move relative to another. So that is, it is not displacing. But it can vibrate in the same position, shaking or vibrating. So space among the particles very less. But here, particles are not orderly arranged. So it can move. So it can move. Particles are closer to each other, so it can relatively move. Relative movement is there. So these forces are not strong as solid, but stronger than gas, right? Not strong as solid, you can write same place maybe, but stronger than gas, but stronger than gas. So particles closer to one, and binding forces are not strong as in solid, but stronger than gas. The particles can move within the liquid, but it is not taking the entire space of the container. Space among the particles is less, but lighter than solid. So here space is less than solid, right? But higher than, space among particles is less, but higher than the solid. Solid very, but still less space than is less when compared to here. Actually, we need to add some point. So this is not clear otherwise. Less when compared with, here please add, when compared with gas, right? Gas already are space when compared with gas, but higher than that of a solid. So you need to always compare with the other status. Okay. Let's move to gas now. Finish.
So should we write the?
Better you add using pencil.
Wait.
Okay.
All right. Sir.
Okay. Then gas. Particles are not strongly ordered. Particles are not strongly ordered or arranged. So they are free. They are free to move here and there. So binding forces among the particles very weak, so they can freely move randomly.
So what's the meaning of binding forces?
Binding forces means the forces which link each other. මේවා බැඳිලා තියෙන බන්ධන. Binding forces. මේවා බැඳිලා තියෙන බලය. ඒ කියන්නේ මේවා එකිනෙකට බැඳිලා තියෙන්නේ. දැන් මේ අංශු තිබ්බට if these particles are there, they are not isolated. Let's see a chalk. Chalk එකක් ගන්නකො. Let's take a chalk. Chalk එකක් ගත්තම chalk කැල්ලක් ගත්තම මේකේ particles තමයි මේ අංශු වලින් හැදිලා තියෙන්නේ. Or take a pastel. It's made up with particles. But there is a bond, right? There is a bond. So how this is bond? Using a binding force. මේවා බැඳිලා තියෙන්නේ මේ යම් බලයකින්. Binding force කියලා කියන්නේ ඒකට. එතකොට අපි හිතමු H2O. So H2O means what? H2O means water, right? So then there's one oxygen and two hydrogens. So that is the particle made up with H2O or this water, and the other one, the other water particle is bounded to this using some force. There is an attraction. මේ දෙක attract වෙලා තියෙන එකට බැඳිලා තියෙන. So that is called the binding force. Right? So I know that you have not learned the atomic view still, H2O bonds, but they are, so you learn about this atomic views and how this happen in these particles and atoms. So you can see this is I think this is going beyond your syllabus, right? But just to understand what happened here, you can see two hydrogens, one oxygen is forming H2O particle, and then here also you can see two hydrogens oxygen and two hydrogens oxygen. So there is a bond, there is a link. These are called hydrogen bonds. Hydrogen to oxygen, hydrogen to oxygen, hydrogen to oxygen, and hydrogen to oxygen, there are bonds. The nature, why this is happening, there is small, right, electricity like thing, a magnetism like thing. So you know, in magnet, north and south. So when you make magnets closer, so what will happen? It will attach, right? Sometimes
Yes,
it will
sir.
detach, right? Magnet, north and south. So basically, so north pole and south pole. You can see when it is opposite pole, it attract. North to south, south to north, it attract. But same pole, it will detach or detract. So that can be repel. You can't call repel. Right? Moving away, moving towards, moving away. I think you know this nature of magnet, right? This
Yes,
is there
sir.
in grade 5, I think, grade 5. Yes. Right? Attract and repel, property of magnet. Similar to that, this plus minus nature, this hydrogen has pluses. And similarly here, oxygen has minuses. So there will be bonds between this plus and minus because these are different type, but plus and plus will actually repel. So, and plus and minus will attract. Due to that, there will be a hydrogen bond bonding these H2O. H2O is the unit. That is the smallest particle of water. H2O single particle has properties of water. ඊටත් වැඩිය බෙදන්න පුළුවන්. ඊටත් වැඩිය බෙදුවොත් අර මොකද්ද මේ ජලාණුව කියන එක තවත් බෙදන්න ගියොත් එතකොට අර ඒ අංශුවේ තියෙන ජල දැසයන ස්වභාවය නැති වෙනවා. We can further divide. We can take oxygen out. We can take hydrogen separately. But that is not H2O anymore. Understood? When you divide a solid or when you divide some matter into smallest particle, you can further divide. But if you further divide, the properties of the particular matter will not be there. Right? එතකොට ඒකේ දැන් අපි තව දුරට බෙදන්න බැරි නැහැ. බෙදන්න පුළුවන්. හැබැයි එහෙම බෙදන්න ගියොත් ඊට පස්සේ පරමාණු විදියට බෙදන්නත් පුළුවන්. එතකොට එහෙමනේ අර පරමාණු බෝම්බ එහෙම හැදෙන්නේ atomic reactions වලින්. හැබැයි එහෙම බෙදන්න ගියොත් අර අංශුවේ තියෙන ස්වභාවය නැති වෙලා යනවා. ඒතර වතුර ජලය කියන්න බෑ අපිට ඒකට. ඒ වෙන එක. Right? Anyway, the smallest particle and how the bonds between the smallest particle, this is called the force. This is called the force. That force is basically what you learn here. That is called binding force. Okay, understood?
Yes, sir.
Okay, then oxygen. So here, see this. So air also has a binding force and solid also here. Carbon bonds. So let's see the carbon bonds and how binding forces are there in carbon. So this shows binding forces in carbon. You can see strong, right? It's strong because sometimes this is not a single bond, that can be double bond or triple bond.
So how can we know it?
Sorry?
How can we know it, sir?
The bonds, you mean?
Yes, sir.
You have to see this through electron microscope, not using the normal compound light microscope. You have to watch this through electron microscope. There's something, so you don't have that in school, and I even don't have. So there are some in some universities. So those are called electron microscopes. Right? So then you can see atoms and these particles here. This is electron microscope view of atoms. Actually, amazing thing was done by IBM. Right? IBM is a computer, like they are producing computers. They have done amazing work with these atoms. Right? එයාලා තමයි චූටිම animation එක හදලා තියෙන ලෝකේ. ඒ කාලේ වෙද්දී ඒගොල්ලෝ කරලා ඒ animation එක හදලා තියෙන කොහොමද දන්නවද? They were moving atoms. Right? They were moving atoms, the small particles, and observed through electron microscope. Here, see this what has done by IBM. Make electron microscope view එකක් තමයි මේකෙත් තියෙන්නේ. So you can just see.
Okay, sir.
IBM Here. Okay, see here, these are atoms, right? So how many times the magnification level? Magnified 100 million times. Amazing, right? So this cannot be done using light microscope. අපේ තියෙන සාමාන්‍ය light microscope වලින් බෑ. කාච වලින් එකකින් බෑ. කාච තියෙන සාමාන්‍ය microscope එකකින් බෑ. So this is magnified 100 million times. Here, this is IBM research. They were thinking whether we can move atom. They have made a film.
Is it the world's smallest film, sir?
Sorry?
Is it the smallest film?
Yes, that is smallest. Smallest means why? Smallest means it is not the length, film length, but actors are super tiny. Because you need to, in order to find the actor, you have to zoom 100 million times. The actors la balanna bෑ. මේක act කරන කට්ටිය බලන්න නම් 100 million times zoom කරන්න. That is why it's called world's smallest. Right? These are particles. These are particles. It has bond. Which I said in the previous state, like it has bond. What they have done, they have given an external force and move these atoms here and there. Since there are bonds, ඒවතර බන්ධනයක් තියෙනවා. ඉතින් බොන්ඩ් එකක් තියෙන හින්දා ඒ බලයක් දීලා තමයි මේව එහාට මෙහාට දාන්නේ. They have given external force to move that. Okay, so you can just further explore, see how the movie was made. So you can see how filmmaking was done. So using the electron microscope, and by just moving these things, you can just go and see this, right? There are videos.
If an atom is the size of an orange, then the orange would be the size of the whole planet. Interested in state movies on your.
So just go through that, and so since we have limited time, I would like to skip this, but you know, there is something like this. Just go and watch and learn this. This is very important science behind the computer. That is how the processor, Intel Atom, and those processors came to the world. Those are having atomic level processing. So that is really amazing technology inside the processor and other components, right? So that is by moving the small particles, purposely moving the small particles. Anyway, so just remember these things: solid organized particles, lightly organized particles in the liquid. So you can say not orderly organized, it's lightly or slightly organized, since it can move here and there relatively. And there is a gap, but that is not a bigger gap, but there is a bigger gap in gas. So you can reduce the gas, you reduce the space in the gas. Therefore, we call it can be compressed, unlike other things. Just take a cylinder, empty cylinder. Right? You know what cylinder is, right? Empty cylinder. Oh, my spellings. Right. Just take empty syringe, and then what you need to do, actually, even though you take empty one, so it is filled with gas. Right? It is filled with gas. Then, so just remove the remove this, right? Remove this part, and you can keep your finger, right? You can keep your finger and compress. Right? How to do that? You can keep the finger and compress. See here.
What will happen?
Sorry, Pute.
What will happen?
What will happen means it will reduce the size. It will reduce the space it takes. But this is only happening in gas. This is only happening in gas, but it's very, very difficult to do that for solid and liquid. The reason is the gap between particles is not much. So you can't take much space. So there is a bus and there is a private bus, okay, in the people. So there are people in bus here and there. When conductor want to load some more people, what he is telling normally? ඉස්සරහට යන්න හරි පස්සට යන්න කියලා කොහොම හරි කට්ටියව තද කරලා ඔක්කොම දානවා ඒ බස් එකට. Have you seen that?
Yes, sir.
Yes, they are putting, that is called compressing. Compressing. Because there are spaces, there are spaces between these people. Therefore, it can be compressed. Therefore, conductor can compress the people and load more people in. Compress කරලා දාන්න පුළුවන්. And there's a story, like old story. You know Andare, right? Right, Andare?
Yes, sir.
Right, he was,
Yes.
there's a nice story. I think you have heard of this. Andare හොඳටම කාලා ඉඳිද්දි තව මොනවද මේ එයා කන්න ආස දෙයක් ගේනවා. හොඳටම බඩ පිරලා ඉඳිද්දි දැන් මෙයා තව කන්න බෑ කියලා ඉඳිද්දි මේ එනාට පස්සේ රස කෑම මොකක්ද මට මතකත් නැහැ. එයා කනවා ඒක. එයා කාලා කියනවා. ඉතින් කොහොමද මෙච්චර බඩ පිරලා ඉඳිද්දි කෑවේ කියලා අහනවා. රජතුමා අහනවා. Then what Andare is telling, Andare කියනවා හරි මම මේක පෙන්නන්නම් කියලා. කාමරයක් පිරෙන්න මිනිස්සු දාන්න කියලා. දැන් රජතුමා දානවා කාමරයක් පිරෙන්න මිනිස්සු දාලා ඉන්නවා. ඊට පස්සේ අන්දරේ කියනවා දැන් රජතුමා එනවා කියලා. රජතුමා එනවා කියනෝනේ මිනිස්සු ටික කොහොම හරි දැන් රජතුමානේ කාමරේ මේ කොහොම හරි අර පිරිලා ඉඳිදි කොහොම හරි එක්කෙනාගේ උඩ නැගලා හරි මැද්දෙන් ඉඩ දෙනවා රජතුමාට යන්න. කාමරේ හරහා යන්න. ඊට පස්සේ අන්දරේ කියනවා එහෙම තමයි මගේ බඩක් කියලා. Right? So likewise, it can be compressed, right? Because there are spaces. Right? That is what happened when empty syringe, when you put the finger and see, this is actually, this practical shows the example. So he's first taking solid, right? He's first taking the solid. These are particles, right? He's making it particles. And then what he's doing is trying to compress this solid.
It does not compress.
Right? It cannot be compressed because then he's put in water and then he put the finger and try to compress. Still not possible because liquid is also very difficult to compress because the space between these particles is not enough. It's not supporting compressing. Then finally he's taking gas. Liquid is difficult to compress. Finally he's taking gas. Okay, this is gas, air. He's trying to compress and it is compressible, you can see. When he push syringe, it can be compressed. The reason, the distance between this intermolecular distance, this is called, but don't learn that word, just learn the particle gap, particle space. But actually it is called intermolecular distance. That is in physics, later you learn that. But it is, since there is a distance, that is the reason why it can become. So you can see here, මෙතන දැන් ඉඩ තියෙනවා මේ හරියට අර බස් එකේ තන තන සෙනගේ ඉන්නවා වගේ. If conductor sees this situation, he will come and compress and put more people in. So that can be done. Or the people can be scattered into small space. So that is what compressing. So why gas can be compressed? Because the intermolecular space, no, not that. So you can tell. So that is also good. But so let's learn it simple way. So since particle space is more, so it can be compressed. Okay, the summary, right, of the things that we have learned today. Shape. Solid has a definite shape. The reason. What is the reason? Why it has a definite shape? Because these particles are orderly arranged. Particles ටික පිළිවෙලට තියෙනවනේ නිකන් ගානට හදලා දැන් මෙයාලා එහාට මෙහාට යන්නෙත් නෑ move වෙන්නෙත් නෑ relative movement එකකුත් නෑ no relative movements they are not moving here and there no free movement therefore it has a definite shape එහෙනම් තමයි shape එක definite වෙන්නේ so but liquid no definite shape හේතුව මෙයාලට relative movement පුළුවන් ඉන්න තැනට අනිත් එක්කෙනාට සාපේක්ෂව අර එමේ දුවන්න පුළුවන් they can relatively move okay think like this. In your classroom, you are compressed. No relative movements. Right? You can't move here and there. You are no relative movement. You become a solid. But normally you are in a class, means you can move here and there. So relative movement is there. So therefore, it has no definite shape. Time to time, if you take a picture of your classroom, students are here and there. So it's not solid. It's not solid since you are moving. Gas, definitely no. No definite shape. It takes the entire space. It's moving here and there, everywhere. That is why when there is a bad smell or good smell, it spreads everywhere, right? Okay, let's say you spread some scent or perfume, then you can smell it. You can feel it. How? Because it spreads. It moves here and there. ඒකනේ ටිකක් වෙලා ගියාම මේ perfume සුවඳ නැති වෙලා යන්නේ.
Yes.
ඔයාලා උදේ perfume ගහලා හවස බලද්දී ඒ perfume සුවඳ එන්නේ නැහැ. මොකද ඒක අර හැමේ ගිහින් හැමතැනම ගිහිල්ලා දැන් හැමතැනම perfume සුවඳ තියෙනවා. But not with you. It has spread. So that is the reason. That is gas. And it has a fixed volume. Fixed volume means the space taken is fixed. Has a fixed volume. Space taken is fixed, but it's not taking the entire volume of the container. It's taking the volume given to it. Let's take glass of water. Glass of water. This is water glass. Let's see. This is water glass and this is the water level. It takes this volume. Not the entire container volume, but it takes the volume assigned to it. But here, if it is gas, it's not, you can't limit it. It's going here and there everywhere, right? If you close this, it will take the entire container. Compressive. Cannot be compressed, but can be compressed because the particle gap is more. Density. Ganatva කියන්නේ density. Density, we learn that in future. So density is very high. So high density, but here density is very low. So highest density is there with solid. The lowest density is there in gas. Okay, other hand, you can say density. Our density means like if you take a unit, how many particles are there for per unit? Per unit particles. Per unit particles කොච්චර තියෙනවද? ඒ වගේ එකක් තමයි density කියන්නේ. Okay, Pute. So I think the lesson is clear with this up to this. Next day, what we need to discuss? We need to discuss activity 4.4. There's a practical and there are few practicals. And we need to learn about the substances and compound substances and all. Okay, and the as I said,
homework?
Sorry?
Do we have homework?
Not for today. For today, you don't have. Actually, so you try to do that time-lapsing thing and finish it. Right? Time-lapsing of what? Time-lapsing of this and not air, but try to do this one. Water beaker time lapsing. You can use, if you have on this, you can use that potassium permanganate. If you don't have that, you can use some ink. Just use food coloring. Food coloring chuttak dala eka spread වෙන එක බලන්න. Food current spread.
Okay.
Then here also, this one also you have to do the time lapse. Other than that, no homework. Just try to do that. Okay, then good night. See you all next week.
Okay, sir. Bye.
Good night,
Thank you,
sir. Thank you, sir.
Good night, sir.